Hello, fifth graders, and welcome to lesson 4.3 on page 245. Today's lesson is multiplication with decimals and whole numbers. The standard we are working on in this lesson is number and operations in base 10, 5.7. It says I can solve decimal problems to hundredths using strategies, concrete models, or drawings. I can explain my reasoning in written form. So, ladies and gentlemen, today we are going to be multiplying a whole number by a decimal. And our essential question is asking, how can you use properties and place values to multiply a decimal and a whole number? Our first question we are going to start with today under Unlock the Problem says, in 2010, the United States Mint released a newly designed Lincoln penny. A Lincoln penny has a mass of 2 5/10 grams. If there are 5 Lincoln pennies on a tray, what is the total mass of the pennies? So, there are a few things that we have to keep in mind as we are solving this question. First of all, they want us to say how much mass does one penny have, and if you look in the problem, it says one penny has a mass of 2 5/10 grams. Then the next thing that we have to look at is how many pennies are on the tray. Well, again, looking in the question, it says that there are 5 pennies. And use grouping language to describe what you are asked to find. So when they are asking us to use grouping language, that means we have 5 groups of 2 5/10 grams. So they have 2 different methods that they want us to show in order to help us understand what our answers should be close to. We are going to find an estimate first. So I know I have 5 pennies, and I know that each penny weighs 2 5/10 grams. Well, I am going to round to the nearest whole number. So if I'm rounding to the nearest whole number with my 2 5/10 grams, remember I'm rounding to the ones place. My 2 is in the ones place, so I need to look at the 5. The 5 does tell my 2 to round up. So to find my estimate, I would take 5 times 3, which we know is 15. So the 2 different ways they have us multiplying, you would really need to choose what method is easiest for you. My opinion, and again, this is just my opinion, the distributive property is not going to be the easiest at first. It is probably going to be better if you would just use your regular multiplication method, but I will show the distributive property here in a minute. Now, for the other way, when they show partial products, again, you don't even have to use the partial product method. We can multiply the 2 5/10 times 5 like they are 2 whole numbers. So we just follow our steps when we multiply whole numbers. So I would start with the 5 times 5, which I know is 25. So I'm going to drop the 5, and I'm going to regroup the 2 to the ones place. Again, I'm going to ignore my decimal right now, and I'm going to then multiply my 5 times 2, which is 10, plus the 2 that I regrouped gives me 12. So I'm actually essentially skipping step 2 and step 3 where they have us having partial products where we're adding together. So now if I was multiplying this like 2 whole numbers of 25 times 5, I would have 125. But ladies and gentlemen, we have a decimal in one of the factors. And so what I have to do when I place my decimal is I have to count the number of place values that decimal factor has behind the decimal. So I see that there is 1 digit behind the decimal. So because there is 1 digit behind the decimal, that does indicate that I would have 1 digit in my answer, so in my product, behind the decimal. So always start from the end of the number, and I'm going to show that that decimal is moving 1 place value to the left, so my decimal would be placed in between the 2 and the 5. So my answer would be 12 5/10. Again, you always start at the very end of the number because all whole numbers have the decimal at the end. So starting at the end of the number, swooping, and that's what we call it, swooping, one place value to the left because my 2 and 5/10 had that one decimal place value. That would give me an answer of 12 and 5/10. Like I said, I did skip steps 2 and 3. I did not want to add any more confusion because we do know that we can multiply these like they're two whole numbers and then just place the decimal at the end. So now, if you would like to try using the distributive property method, this is just like multiplying with whole numbers, except for the one major difference is that decimal. So whenever you use the distributive property, there is always one factor that you have to break apart using addition. And with our decimals, it would be the decimal that you would break apart. So the 2 and 5/10, I'm going to break that up into 2 plus 5/10. If we add that together, we would still have that 2 and 5/10. So now remember, the next step is to always multiply or distribute the number that is outside the parentheses by both numbers inside the parentheses. So my first one would be the 5 times 2, and then they have the 5 times 5/10. So when I do my 5 times 2, I know that that equals 10. And 5 times 5/10. So I'm going to multiply those like they are two whole numbers, and I know 5 times 5 is 25. However, again, when I multiply decimals, I have to count how many decimal place values my answer should have, and that is coming from one of those factors. So the factor that has the decimal has one decimal place value, so that means my product needs to have one decimal place value. So now when I add these together, I know that I would have to take 10 plus 2 and 5/10, which would give me the final answer of 12 and 5/10. Now this method might not be as easy if you're not comfortable with multiplying decimals, so I strongly suggest, until you get comfortable with it, that you would just do the normal way of multiplying like they're whole numbers and then placing the decimal at the very end. So to answer our final question, they wanted to know the mass of 5 Lincoln pennies, and we just found that it was 12 and 5/10. I do know that my answer is reasonable because my estimate was 15, and 12 and 5/10 is very close to 15. Moving on to the next page. So having a thickness of 1 3500 millimeters, the dime is the thinnest coin produced by the United States Mint. If you stacked 8 dimes, what would be the total thickness of the stack? So again, I'm taking the thickness of one dime, and I'm going to multiply it by the number of dimes that I have. So 1 3500 times 8. Again, just like I told you, we do multiply like these are two whole numbers. So that is why they are showing 135 times 8. So when I do this, I would have 1080. They did the work for us on this. But because I have a decimal, I do have 2 digits behind that decimal place value. So that means my answer will have 2 decimal place values. So just rewriting the answer that they found with taking 135 times 8, starting from the end of that product, I'm going to move 2 place values to the left and place my decimal. Again, I got those 2 place values because my top factor did have 2 decimal place values in it. So I just count the digits behind that decimal. So I do know that a stack of 15, oh sorry, that should be 8 dimes. A stack of 8 dimes would have a thickness of, we could either write 10 and 80 hundredths, or I do not need the 0 behind the 8. I could also just say 10 and 8/10. So now I'm just going to move down to the share and show, so that way we can practice placing our decimals, and then on the next page we will then just multiply like they're two whole numbers and then place our decimal. So for question number 1, they did solve it for us. We are just going to practice placing our decimal. So I'm going to count the number of digits behind the decimal. So for my 6 and 81 hundredths, I see 1, 2. So I have 2 decimal place values. So that means my answer has to have 2 decimal place values. So starting from the end, swoop 1, 2, place the decimal, and I would have an answer of 47 67/100ths. For question number 2, if I would multiply 37 times 2, that would give me 74. But because I have 3 7/10, I need to place my decimal. So I have 1 digit behind my decimal, the 7. So my answer should have 1 decimal place value. So starting from the end of the 74, swooping once to the left, places my decimal in between the 7 and the 4. So I have an answer of 7 4/10. Moving on to number 3, if I would multiply like they are 2 whole numbers, I would have 1,934 times 5, which would give me that 9,670. However, in this question, we do have a decimal of 19 3/400ths. So counting the number of digits behind my decimal, I have 1, 2. So 2 decimal place values, and my answer is what I need to have. So swooping 2 to the left places my decimal in between the 6 and the 7. So 96 70/100ths. Moving on to page 247, this time I am going to actually multiply with you and then place our decimal at the very end. Remember, multiplying decimals, you work with the decimal last. So for question number 4, I am going to rewrite it a little bigger. I struggle writing that tiny. So I have 6 32/100ths times 3. Ignoring my decimal, I'm going to just go ahead and multiply the 3 to everything in the top factor. So 3 times 2 is 6, 3 times 3 is 9, 6 times 3 is 18. So now, counting up the number of digits behind my decimal, I have 1, 2, so that means I need 2 decimal place values. So from the end of that answer, swoop 1, 2, place my decimal in between the 8 and the 9. For number 5, again, rewriting it to make it a little larger for me, I have 4 5/10 times 8. Multiplying the 8 out, I have 8 times 5, which is 40. Carry my 4. 8 times 4 is 32, and then 32 plus 4 is 36. So now to place the decimal, I see 1 digit behind my decimal, so that means my answer must have 1 decimal place value. From the end of my answer, swoop once to the left, place my decimal. So my answer, I could either write the 36 and 0/10, or I would just write the answer of 36. Technically, you don't need that 0.0. On number 6, I have 40 7/10 times 5. Multiplying the 5 out, I have 5 times 7, which is 35. 5 times 0 is 0, plus 3 is 3. And 5 times 4 is 20. Now to go to place my decimal, I see that my top factor has 1 digit behind the decimal, so I need to have 1 decimal place value in my answer. So starting from the end, swooping 1 place to the left, put the decimal, and I would have the answer of 203 5/10. So at this point, you should pause the video, solve 7, 8, and 9 on your own, and then once you have those solved, you can turn the video back on and I will reveal the answers. Alright, so for number 7, we have 4 93/100ths times 7. 7 times 3 is 21. 7 times 9 is 63. 63 plus 2 is 65. And 7 times 4 is 28. And 28 plus 6 is 34. So now I have to count the number of digits behind my decimal. I have 1, 2. So my answer must have 2 decimal place values. So from the end, 1, 2 to the left, place my decimal, and I would have the answer of 34 51/100ths. So now I'm going to multiply 8 and 2/10 times 6 for number 8. 6 times 2 is 12. Carry my 1. 6 times 8 is 48, plus 1 is 49. Count the number of decimal place values in the top factor. I see 1, so that means my answer must have 1 decimal place value. So from the end, swooping once to the left, places my decimal in between the 9 and the 2 for 49 and 2/10. Finally, for number 9, I have 7 and 55/100 times 8. And when I multiply this out, I have 8 times 5, which is 40. 8 times 5 is 40, plus 4 is 44. 8 times 7 is 56. 56 plus 4 is 60. So now to count the number of digits behind my decimal, I have 1, 2. So 2 decimal place values need to be in my answer. So from the end of the number, 1, 2 to the left, place my decimal, and I would have the answer of 60 and 40/100, or you could only put just 60 and 4/10. All right, to set up your homework with you, on page 249, you are going to do all of the odd problems except for number 17. So circle 3, 5, 7, 9, 11, 13, and number 15. So looking at the top of the page, you do just have to multiply. Make sure you're placing the decimal in the correct location. Remember, when you type in your answer, the period key is the decimal key for typing in your answer. Obviously, for 7, 9, 11, and 13, make sure you are stacking your factors. So, and I would stack the factor that has more digits on top, so that way you are able to multiply a lot easier. Again, make sure you're counting the number of decimals that are in the top factor, and that would be the number of decimal place values you need for your answer. And then for question number 15, it says a $50 coin issued by the United States Mint measures 30 and 61/100 millimeters across. Mick has 9 $50. He lines them up end to end in a row. What is the total length of the row of $50? So obviously you're taking the length across that $50, which is 30 and 61/100 millimeters, times the number that are lined up end on end, which was 9. So that would give you the total length in millimeters when you solve. On the back, on page 250, Pete wants to make turkey sandwiches for 2 friends and himself. He wants each sandwich to contain 3 5/10 ounces of turkey. How many ounces of turkey does he need? So we have to make sure that we have enough sandwiches. So it's for 2 friends and himself. So that means 3 people need a sandwich. So you are going to take the 3 5/10 times 3, and that will give you your number of ounces of turkey you would need. Number 2, gasoline costs $3.37 per gallon. Mary's father puts 9 gallons of gasoline in the tank of his car. How much will the gasoline cost? So to find our total cost, take 1 gallon times 9, and that will give you your total cost of how much money it would take for 9 gallons of gas. For question number 3, a group of 5 boys and 8 girls goes to the fair. Admission costs $9 per person. What expression can show the total amount the group will pay? So they are asking for the expression, so we are not solving this. And it really doesn't matter who is going, whether it's boys or girls. You need to figure out the total number of people going, and that would be placed inside parentheses. Figure out how you would find the total number of people going. Then it says the admission costs $9 per person. So once you have the total number of people solved inside the parentheses, then you would multiply by 9 to figure out the total cost that the group will have to pay. For number 4, Sue and 4 friends buy a box of 362 baseball cards at a yard sale. If they share the cards equally, how many cards will each person receive? So first of all, we do need to figure out how many people are sharing these cards, and it says Sue and 4 friends. So that means there are a total of 5 people that are sharing these cards. And if you share equally, that tells us that we have to divide these 362 cards up between those 5 people. So I already know that this will not give me an even answer. This does give me a remainder. So I'm going to have to interpret the remainder. Now obviously, you would not want to cut a card in half, so we're not going to have a fraction in our answer. And we can't just add 1 to the quotient, because then we would just be taking a card magically out of the air, and that's not possible either. And we do also know that if you would just use your remainder, you're going to have a bunch of other cards that are not being divided between the 5 people. So what we are going to have to do is we are just going to have to use our quotient as our answer. Yes, there will be cards left over, but as of now, you would have to assume that those cards would then just be given to someone else. For question number 5, Sarah rides her bicycle 2 7/10 miles to school. She takes a different route home, which is 2 5/10 miles. How many miles does Sarah ride to and from her school each day? So we are trying to find the total number of miles. So to find the total, we would add her trip to school plus her trip home. So make sure, remember when you are adding this, you're dropping the decimal straight down. For number 6, Tim has a box of 15 markers. He gives 3 markers each to 4 friends. What expression can show the number of markers Tim has left? So again, we're trying to find the expression. We are not solving to figure out how many markers he actually has left. So we know we need to start with 15. And we know that there are 4 friends, and each friend is getting 3 markers. So you are going to have to figure out what you need to do with that 3 and 4. What operation is that each telling you to do? If you have any questions, please let Mr. Reindel or I know. And I hope you have a great day. Thanks.